let's get started. So, just like we did the first section, we spent 2 days on. The first day was really all the information. Second day is a little more practice. That's what we did yesterday. We're going to do the same thing, but with the rectangles and the rhombus, and proving it using the different properties. So there'll be a lot of stuff today. We'll practice today, and then have the weekend, come back on Monday and do a little bit more so you can get better at it. And it looks like we have a review on Tuesday. I know there's a field trip on Tuesday, so if you're not here, just know that's happening. We're reviewing in class, and Wednesday will be the test, which covers everything from the last quiz as well as the past few days. Okay. So first things first, let's go over what the rectangle is. Okay. Definition-wise, it's a quadrilateral with four right angles. That's all it is. And remember, 4 right angles is not a square. Square is when you combine a rectangle and a rhombus together. So the 4 congruent sides comes from the rhombus. So keep in mind over here, when we're proving a rectangle, really we only have to show that one of them in a parallelogram is a right angle, because if one of them is a right angle, just by the geometry of everything, the others have to be as well. Okay. So even though that has 4 of them, you just get to pick one of them to try to prove that they're opposite reciprocals. Okay. And there's many ways of proving something's a rhombus, but definition is all 4 congruent sides, but that means you have to do the distance formula 4 times and show it's identical. So it's quite a bit of work. But there was another property about the rhombus that said the diagonals are perpendicular. So if we're using the diagonals instead of 4 congruent sides, you only have 2 sides you have to work with, and then you only have to deal with the slope, and you don't have to touch the distance formula at all. So in general, between slope and distance formula, you kind of want to go with slope. It's just easier to count the squares than it is to do the whole formula. Okay? And don't forget that just to prove it's a parallelogram, before we can show it's a rectangle or a rhombus, it has to be a parallelogram first. And there are 2 ways of doing it. Once again, one of them is to show opposite sides are congruent, which involves the distance formula. Right? And the other way would be to show that they're parallel. Right? And that is there we go. And that is when they have the same slope. So 2 ways, and you get to pick. It doesn't matter which one you use. Slopes are probably a little easier. We'll do one of each just to cover our bases. Up above was just an exercise of showing by definition. If we're going to use the definition to prove it is a rectangle, something's a rectangle, you're technically checking all 4 angles. Just know that when we're doing it in our problems, though, we're using the theorem that says really you just have to check 1. But if we're going to check all 4, that would mean 4 different right angles, which means 4 sets of slopes that are opposite reciprocals, right? So you'd have to show, I can write them out. Basically, you have to show that WZ would have to be perpendicular to YZ, right? Then you'd have to show YZ is perpendicular to YX, right? Then you just keep on going. Then you'd have to show YX is perpendicular to 4th side, which is WX. And then lastly, circle back around, we'd have to show WX is perpendicular to where we started with WZ. So By definition of a rectangle, which has 4 right angles, we have to do all this work. Okay. So not too pleasant, but we could do it. So just to cover our bases, let's go ahead and just really fast find each one of these. So slope of WZ, be up 1, 2, 3 over 1, 2, negative, because I went to the left. And then the slope of YZ, right here, would be up 1, 2, 3, 4. To the right, 1, 2, 3, 4, 5, 6. So that's 4, up 4, right 6, which reduces to positive 2/3. So are these perpendicular? Opposite, right? One's negative, one's positive. Yes. Reciprocal, 3 over 2, 2 over 3. So yes, those are perpendicular. And the other mathematical way I've mentioned before to show they're perpendicular is if you multiply them, they do equal -1. And another, more numeric way of figuring out if it's perpendicular. So basically, the negative and the positive make a negative, right? And the reciprocal properties make everything cancel out. So that's where the 1 comes from. So 2 different ways. You can actually just visually look at it. Are they opposites? Are they reciprocals? Or you can multiply them and see if the answer is -1. It's the exact same thing. Either way is fine. But that's the process. So then we go through and you have to do that 3 more times. So YZ, we already know is 2 over 3. Then we'd go over here to YX and find the slope, which is up 1, 2, 3, left 1, 2. Okay. And no surprise, are these opposites? Yep. Are they reciprocals? Yep. Therefore, they're perpendicular. And if you want to use the other property, they do multiply to -1. And we just repeat that 2 more times. So YX, is that perpendicular to WX? We already know. WX is up 1, 2, 3, 4. To the right, 6. Same as up here. So we know that's going to be 2 over 3. So a lot of repetition, just like you saw yesterday. There's nothing groundbreaking here. These are perpendicular, opposite reciprocals. And then do it 1 more time. So which would be 2 over 3 and 3 over -2. And that would make those perpendicular as well. And all these multiply to -1 as well. Okay. So just to review, I don't think we need to go through these other ones just to repeat that process, because really, we're really going to use this property right here, where we just have to do this 1 time, not 4 times. Okay. So step 1 for all of these is going to be trying to show, is it a parallelogram, and if it is, if yes, so you're going to try, if the answer is yes to this question, we're going to go here and here. We have to do both. If the answer is no, okay, you stop. Because if it's not a parallelogram, it's not going to be a rhombus or a rectangle. That's impossible, right? So the answer to the first question will dictate whether you have to do the next 2 or not. So on each of these problems, you see there's 3 places, right? Right here, and right here. So is it a parallelogram? Is it a rectangle? Is it a rhombus? So if the answer to the first one is yes, then we have to do the next 2. If the answer to the first one is no, then we just X out the next 2 questions because it's impossible for it to be one of those 2 if it's not a parallelogram. So I just put that out front because some will miss that, and then when it's not a parallelogram, they'll try to be proving it's a rectangle or something, which is impossible. Okay. So let's start off by using, remember we have a choice on this first step. You could do, is it congruent or are they parallel? So let's start off by just doing the distance formula 1 more time on all these and see what happens. Where were we? Okay, so let's get started. Start by plotting these points. Now, believe it or not, this is one of the most important parts of the whole problem. If we don't plot these points correctly, of course, everything else might go wrong afterwards. So be very careful. Make sure we do this accurately. Do this in orange. So we got A is at, let's see, -7, +3. And it helps to label them. Well, so that's A. And then B is -2, 3. -2 up 3. There's B. A little bigger. There we go. And then we have C is at 1, 7. And D is at -4, 7. So let's do black. So look in this first reaction here. Does it look like a parallelogram? Does it look like a rectangle? No, it doesn't look like it has 90-degree angles. Does it look like it's a rhombus? Yeah, maybe, maybe not. So before you start doing any calculations, kind of get a gut feeling like, yeah, this doesn't look like a this doesn't look like it has 4 right angles, right? So as you're doing the work, you kind of already know what to expect. As far as, is it a rhombus, like do all 4 sides look like they're congruent? Or maybe this is right here is a little bit shorter than this. It could be just a little bit shorter or a lot shorter. Or it could be the same and it's just kind of the way we drew it doesn't look congruent. So we'll put it down for a maybe. But then we're going to verify everything numerically with numbers by doing distance formula and the slopes and all that good stuff. Okay. So let's go back to this and start the process just like you guys practiced a few times. If we're going to show by distance formula as a parallelogram, we got to show 2 pairs of congruent sides. So we got to do, in any order really, show that AB, right, that AB and DC are equal. Remember, when there's no m's or anything, we're talking about the length or the distance, right? And then we'd have to also show the other opposite sides are congruent. So we'd have to show AD, see here, is equal to BC. So 4 distance formulas all together. Okay. And then just do the work carefully, make sure we're not missing anything. So finding, let's see, the rise and the run basically to throw in the distance formula. So from A to B, the rise is 0, right? The run is 1, 2, 3, 4, 5. So for as far as distance formula, that's going to be 0 squared plus 5 squared, which by no surprise is just square root of 25, which equals 5, which we could probably figure out just by looking at the graph, right? We knew this was 5 all along, 5 squares. A little bit easier to figure out the distance of something when it's horizontal and vertical. Distance formula is really more useful when it's a diagonal and you can't just count squares. But we'll just be thorough and show the calculations anyway. Not something you would normally do. Both sides come out to be 5. So yes, these two are congruent. So we're halfway there. We've proved it's a trapezoid since we have, I'm sorry, no, we just proved 2 sides are congruent. We got to do the other side. Trapezoid is for parallel. All right, and this repeats the same process, but now we have diagonals, so we have more of a use for this formula. So the rise is going to be up 1, 2, 3, 4, 5. Yep, or 4. Yeah, up 4 to the right, 1, 2, 3. So for AD, we're going to have 4 squared plus 3 squared. And then we have, that's 16 plus 9, which equals 25. Square root of 25 is 5. And then we just have to show is the opposite side the same. So count those, up 1, 2, 3, 4, and to the right 1, 2, 3. So it looks like the rise and the run are the same. So when we do the distance formula, it should come out to be the same. So we got 16 plus 9, square root of 25, which equals 5. So therefore, it is a parallelogram since, and just describe what we just did, we showed both pairs, right? And pairs of what? These are pairs of opposite sides and what do we show about them? Right? They are congruent. Are congruent. So on your test next week, you're going to have to give this statement. Actually write this whole thing out. Like, how come this is a parallelogram? And you'll have to write out this whole sentence. Okay, so that's why it's on every problem, and you have like a sentence frame to fill in on every problem, because you're going to actually have to write that out on the test. So please practice. It's going to be the same thing. Either it is or it is not. You can say it is because both pairs, opposite sides, are congruent, or you could say it is not because both pairs of opposite sides are not congruent. So if you use the word not here, you just insert the word not here. Right, and those are your two options. Okay. So since this is a yes, since it is a parallelogram, then when yes, we go down to the next two and check to see if it's a rectangle and if it's a rhombus. Check them both. Okay. So rectangle, recall, we just have to check any one angle and see if it's a right angle. So we can check either A, B, C, or D. It doesn't matter, but we just have to check it. Okay. So I'll stick with angle A. So what I'm going to try to show is let's see what I use here. I got to show one of these statements, right? It's something perpendicular to something. So is AB perpendicular to AD? And since this is on a coordinate, you should be looking at it and say, yeah, that ain't no right angle. So you expect the answer to be no, but you want to prove it numerically as well. So AB, let's find the slope. Okay. So the slope of AB, right, is up 0 over, I think it was 5. So 0 over 5 is just 0, right? And then find the slope of AD, which is up 1, 2, 3, 4 over 3. So are 0 and 4/3 perpendicular? Right? Not perpendicular. Another way of looking at it is, do these two numbers multiply and equal -1? You know, like we did here? No. They don't multiply and equal -1. So it is not a rectangle, since one of the angles of the parallelogram is not a right angle. So next is to check to see if it is a rhombus, right? And the easiest way to do that is usually to check to see if the diagonals are perpendicular. So we don't have the diagonals drawn on here, so probably want to draw those out first. So from here to here, right, that's one diagonal. And from here to here, there's another diagonal. And we want to show if these indeed make a right angle. Does that look like a right angle to you? Yeah, possibly, maybe, yep. So we're kind of expecting it. So let's prove it though. So we got to show AC and DB are perpendicular. So is AC perpendicular to BD? And we're just basically doing the same thing we just did with the rectangle. With any two sides, we're going to do it with the two diagonals. And there are only two diagonals, so these are the two sides, or the two segments you have to use. So slope of AC, find the slope of AC. Go back up here, count the squares. We're going to go up 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5, 6, 7, 8. Did I count that right? Yeah. 4 over 8? So up 4 over 8. Okay. So 4 over 8 would be 1/2, right? Okay. And then do the same thing, slope of BD. What is the slope of BD? Help me out. Up 1, 2, 3, 4. To the right, 1, 2. So we had 4 over -2, which equals -2. Okay. So are these two perpendicular? 1/2 and -2? Yep, opposite, because this is positive 1/2, -2, and reciprocal, 1 over 2 and 2 over 1. So therefore, these are perpendicular. Therefore, it is a rhombus. So we can say it is a rhombus since the diagonals of the parallelogram are perpendicular. All right. So it's not so much that you're going to do this and find out if it is or isn't. We already had a really good idea just by looking at our graph up here that it is going to be a rhombus. It looked really close. And most of you, or some of you probably caught this, is that we already kind of proved it was a rhombus earlier, right? We already showed the length of every side here was 5 for both of these, and it was 5 for both of those. That's the definition of a rhombus, is that all 4 sides are congruent. So we kind of already showed it here, but wanted to show it using the theorem as well. So definition, if you just had to show it's a rhombus just by definition, it's 4 different calculations, kind of like the definition for the rectangle is 4 different calculations. But using these theorems, it's just one calculation here, one calculation here. So a lot easier, so I want you to be able to use this diagonal theorem. All right, so let's do just one more. And this time, well, we started off with saying you have a choice. Show the sides are congruent or show they're parallel. So let's do the second part here and show this time that the parallelogram is has 2 sets of parallel sides. And but first, plot them out and be careful. So 1, 2. E, 4, 4 is F, 5, 1 is G, and 2, -1 is H. And let's get a first impression of what we think it might be and might not be just by looking at it. Okay. So first impression, does it look like a parallelogram? Nope. Okay. Well, if it's not, then we can't do anything after that. So let's stop and just figure it out if it's a parallelogram or not. So we got to show by definition that EF is that parallel to GH, right? So is the slope of EF the same as the slope of GH? Okay. And just count it out and find out. So EF is up 1, 2. The run is 1, 2, 3, 2 over 3. And then do the same thing for GH. Up 1, 2, to the right, 1, 2, 3. So far we do have a trapezoid. We got one set that's parallel. So keep going and see if the other pair right here are these parallel. So we got to show, is the slope of EH the same as the slope of FG? Okay. So we got H, we got to go up 1, 2, 3, and left 1. So up 3, left 1. And then for G, we got to go up 1, 2, 3, left 1. So it looks like they are the same, right? So these are now parallel, and we do have a parallelogram. So you did hear some people say, I don't think it is parallelogram. This is why we do the numbers. That's what the expression comes from, by the numbers. Don't just do it by how it looks, do it by the numbers. And if the numbers are say it is, then it is. Whether we think it looks like it or not, that's just an opinion and an estimation. Numbers are very concrete. So we're going to say, yes, it is, since, and it's going to be very similar wording. We did over here, both pairs of opposite sides are congruent, but instead of congruent, we showed both sides are parallel. So we just changed that last word to parallel. Since both pairs of opposite sides are parallel. There we go. And then since we got a yes here, we do have to go through and check the next rectangle and rhombus. And first impressions, this time it looks like it could be a rectangle. This might be a 90-degree angle, right? And it could be a rhombus. I don't know, maybe this looks a little bit too short to be the same as this. Can't really tell. But let's do it by the numbers and see what happens. Okay, so for rectangle, we need to draw a, let's see, oh no, for rectangle, we just need to do the slope, that's right. So we just need to show, pick any one angle, I'm gonna pick H here, and show is EH perpendicular to GH, right? So my question is this, EH perpendicular to GH, yes or no? Then we find the slope of EH, which we kind of already did over here. Slope of EH is -3 over 1. And the slope of GH, we already did over here, is 2 over 3. Okay. So are these perpendicular? No, so not perpendicular. So it kind of looks like this might have been a right angle, but yes, when we do it by the numbers, it is definitely not. It wasn't that far off. If this was a 3 over 2 instead of a 3 over 1, then the answer would have been yes. Okay, so is not a rectangle, since one of the angles of the parallelogram is not a right angle. Okay, but it could be a rhombus. So let's check that. So we got some diagonals to draw and find the slope of. There we go. Okay, so we're trying to show, is EG perpendicular to FH? Is EG is that perpendicular to FH? And once again, oh no, we don't have those up here because these are diagonal, so we have to count them out. So EG, we have to go up 1 and left 1, 2, 3, 4. So 1 over -4 for EG. And now do FH. So we have to go up 1, 2, 3, 4, 5 over 2. 5 over 2. So are these perpendicular? Nope. Not perpendicular, therefore it is not a rhombus since the diagonals are not perpendicular. Okay. So you just have a few problems to practice on the back. I will tell you one of them does not come out to the parallelogram at all, so you don't have to do all 3, and the rest do. And if you're not sure about the wording here and how I'm getting these, it comes directly from here. Okay, so the wording for at the end of each of those is exactly this, just with missing words. Okay, so it's nothing different. Okay. All right, you have a little bit of time in class, probably about 20 minutes. You might be able to get all this done, and so you're finished for the weekend. All right, go ahead and get started.